Okay. Right. There's one prize left. That's the silver medal of the EMS. And what I'm going to do now is first I will read the citation, hand over the silver medal and the certificate to the winner, and then we'll ask Alain Ratier to do the laudatio, and then the silver medalist to deliver his presentation. It's not a surprise because it was published already in the booklet. Anton Helgesen from Norway, the director of the Norwegian Med Service, is the winner of this year's Silver Medal Award. And I read out the citation. For his scientific contribution to environmental meteorology, his outstanding service to the European and international meteorological community, and his major role in increasing and enhancing the public understanding of meteorological information through his effort to make meteorological data freely available. So, Anton, there we are.
So, dear colleagues, dear Anton, first of all, it's a great pleasure to be here. I see faces which I don't see so often, and it's a great pleasure. And I remember with Harry Houghton some discussions also on how ready he was to pay for very good data, and he confirmed with his CMWF data today. So he's a very stable and reliable person. So the scientific achievements of Anton Helgesen are well known, in particular in the areas of atmospheric pollution and understanding of acid rain, which was a major topic some time ago. As a researcher, Anton, you were a real pioneer of modeling of the long-range transport of atmospheric pollutants. So transport is very short. It's much more than that. It's dispersion, it's deposition. It's a very complex problem. So a few months ago, I had a conversation with him, and we have many. I told him, but what did you bring? What made you this pioneer? I said, it's very simple. I brought the scientific heritage of the Bergen School of Meteorology together with the heritage from the Turbulent School in Russia, so Kolmogorov and Bjerknes. It's very simple. It's typical Anton. Things are very simple, but illuminating, you know. It's, yes, it's very clear. And conversations are always fascinating with Anton. And you gave an award about meteorology and art, and we have always discussed music and science, and recently we have approached painting, talking about Edvard Munch and Nicolas de Staël. But what is fascinating is the way he talks about science, and you have the impression that equations of fluid dynamics are the part of the music of Mother Nature. At least this could be the score. But as we all know, Anton has also played a key role as a leader in the development and governance of meteorology in Europe. Some may say this is because he has outlived most of the directors of his fellow directors. It's actually true. But I think it simply reflects his merits. And recently the Norwegian government asked him to stay while he could have gone to pension. But with all due respect to others, Anton is one of the very few combining managerial and leadership skills with a scientific vision. And, last but certainly not least, he has a fast and in-depth understanding of sensitive issues such as data policy and also European cooperation models. So, he's, as a matter of fact, his natural authority, and I will come back to that, and his commitment to serve the common interests of the meteorological community made him the most trusted partner, the most trusted leader in the construction of what is called today the European meteorological infrastructure, combining the national Met services, ECMWF, and EUMETSAT. And indeed, he's been the president of ECMWF, and is now the chairman of EUMETSAT, of the EUMETSAT Council. In all difficult times, and there were difficult times, and I will give a few examples, he remained instrumental to resolve critical issues and to find the consensus which is necessary to continue to progress. For instance, as a chairman of ECOMET, because he was also the chairman of ECOMET until recently, in the sensitive area of data policy, he proved to be the excellent mediator between NMSs and the private sector, represented by Primet and others. And he organized a famous conference in Oslo to try to achieve a compromise between the national Met services on data policy. And he achieved this with the so-called Oslo Declaration. So it was bringing EUMETNet also on the table, on the scene. And this Oslo Declaration is still current. And it's a very good reference for all those who want to progress in delivering more good quality data free of charge. So he's been also the president of the ECMWF. And I said there were difficult times. Yes, there were difficult times. He was president at a time where one member state challenged the ambition of the center to buy a new HPC system. And Dominique, I see, is smiling because he remembers very, very well. And actually, they were also challenging a bit the value of the center for its member states. So there was a programmatic task force, I think this was the name. And it reported to Council. And the center survived and further developed. Recently, in EUMETSAT, he had a few interesting situations to manage as well. We had 3 big programs to approve, unanimously, not so easy. The EPS second generation program, the JSON CS program is not yet approved, but it should be in 2 days. And last but not least, the contribution of EUMETSAT to Copernicus. And this was something outstanding because we get the proposal tabled at the Council, believe it or not, because it's a bit complex when you talk with Brussels. So, of course, when we entered the Council room, some delegations said, we cannot approve something which is tabled. In the end, it was unanimously approved. So, you see the level of trust which is required from Anton as a chairman of the Council, and this was achieved. I will never forget his smile, because you have seen his humor today, but you have not seen his smile of satisfaction when he has achieved something. That's certainly something you don't forget. So, also in a recent conversation, we talked about his natural authority. And he told me one factor is that he is never impressed or stressed by any adverse or aggressive statements. He does not care much. And he told me this dates back to one day where his father, a famous meteorologist, Anton Helgesen, kept a long silence after reviewing some of his work because he believed it was not as perfect as it should be. And since that time, Anton told me, silence has more impressed him than adverse statement. And this is one explanation of his resilience. After he told me that, I have to tell you, I have observed his silence at the council, because he does not talk much, he just talks as necessary. This is a feature of his personality. But sometimes there are long silence as well, and yes, it means something. It's a bit like Mozart, you know. You have the notes and the silence, but it's still Anton also in that case, and it's part of his leadership. So, to conclude, dear colleagues, I think these awards rewards the commitment of an exceptional leader to meteorology in Europe. He has always voiced and championed the common interests of the community, sometimes even against his own interests. And he has always achieved this, combining his own vision with his ability to listen. It's very important. Pragmatism with ethics, integrity. That's why he's so trusted by others. And courage and respect of others. Thank you.
Thank you, Alain, for that laudatio. And all that remains now is, first of all, show you the medal. Should not have missed that. And there we are. Okay, you can kill that now and put that presentation on. Okay, Anton, you're on. It's forward and backward.
Thank you.
Okay.
Well, I'm most honored. I absolutely did not expect this, and I nearly had, the pollution work is some time back, you know, so I had to review what I had been doing then. I left it around 2000, I think. And concerning the Oslo Protocol that Alain mentioned, I think he was then representing at that meeting Meteo France, and while we others were drinking wine in the evening, he was drafting the most sensitive paragraphs of the Oslo Protocol in his hotel room. So I think he should also have some of the honor of the Oslo Protocol on trying to agree on the data policy. So you never achieve much without very good cooperation with the persons around you. That's very important. Now I try to review some of the things I've been involved in along the years, and I started as a scientist at the Norwegian Institute for Air Research in 1972. Seems a long time back, but that was on a large program on transboundary air pollution and acid rain. People then believed that sulfur didn't go more than 50 kilometers, and they used Gaussian plume models and so forth, and gradually it turned out that this sulfur traveled much longer, and that also applied to nitrogen oxides and a lot of other pollutants. And at the political meeting, a KSSE meeting in Helsinki in the mid-70s, it was decided that East and West Europe should do something together on environmental issues, and it turned out to be transboundary air pollution. And in Oslo we were supposed to calculate how much pollution crossed the borders and went from one country to the other in Europe. And we still do that job, but I'm not involved in it anymore. And here is now the current emission of sulfur dioxide in Europe now in 2013. You see the ship emission is significant. This was small in 1980. This was very much large emission, and it gave a lot of damage, and you all remember the damage to the German forests and the Erzgebirge and all that. And now this is a problem which is forgotten. And it is forgotten because it's not a problem anymore. And that's good. So just forget it. But it was once a problem of high political importance as well. And there is something called the Convention on Long-Range Transboundary Air Pollution, which entered into force in the mid-80s, and under which all this work has been going on. This is total deposition of sulfur in milligram sulfur per square meter, and this is calculated by our model. We had one calculating center, and there was another one in Moscow for many reasons, also political, and we had a lot of cooperation with East European scientists also in that time, and we were, I think, privileged to travel around in East Europe and discuss all these issues at the institutes. Also here in Sofia, I was here first time in 1979. So then we, under this convention, which encompasses about 50 parties in Europe, we had ecologists working on how much sulfur deposition, how much acid deposition, how much nitrogen that the ecosystems could handle without being damaged. And here you see such a map, and in each grid square of 50 by 50 kilometers, we had the frequency distribution of the critical loads. Some ecosystems within that grid square was very sensitive, and some were not so sensitive, and for each grid square we had the frequency distribution of critical loads, and that we could compare with depositions, and then we could calculate the excess deposition above the critical load. That's very easy. You take the total deposition and you subtract the critical load, and the remaining deposition is the harmful part, and that's what you're supposed to reduce. And this was the basis for the Göteborg Protocol, which managed to, or at least contributed to, reducing the traditional emissions very strongly from 1990 to 2010. And there was perhaps a somewhat advanced thinking as a basis of this protocol, because it is slightly more difficult in many ways than CO2, because sulfur falls down, nitrogen falls down. So for each country we had made maps such as this. This is where German sulfur ends up. And if you have such a map for every country, you can say where it lands and what sort of damage it does or contributes to where it lands when you have the critical loads map. And then also for each country we had a cost curve for what it cost to reduce emissions of that country. And some measures are very cheap, and some countries had already implemented those measures, and some measures are very expensive, and many countries had not implemented the expensive measures. But then if a country had not implemented much, then they would have to reduce, and if a country had implemented a lot, this would generally mean that it was very expensive to reduce further. And if we had this type of curve, you can imagine that you spend 100 or 1 million euro in each of the countries, and you can see to reduce the emission from that particular country, and you can see where you should spend the money in order to get the largest reduction of excess deposition above the critical load per euro. And then you reduce in that country, and then you create a new situation, and you go around once more, and you continue until you have spent your money, or you have achieved your environmental goal. And we had an environmental goal which was to reduce the excess deposition by at least 60% in every of the grid points you see on that figure. So at least 60% in every figure. And if you have 50 countries, you have 50 national reductions to play with, and you have about 1,000 grid squares, so you have a problem where you have 1,000 conditions and 50 variables, which means you must overfulfill in most of the grid squares in order to achieve the 60% what we call gap closure in some of the most difficult grid squares. And one of the most difficult grid square was in southern Norway, and there we have the most expensive trout in the whole world. If you calculate the costs of emission reduction in order to save the trout in those rivers. So I have once thought I should invite scientists to the most expensive trout dinner in the world, but I haven't gotten around to it yet. So you can't work in this without having a little bit humor in the work, because it was very political. So then we did all this calculation and cooperated with the International Institute of Applied Systems Analysis in Luxembourg by Wien, IASA, and they had a mathematical routine which was not iterative as I described, because if you use the iterative routine, you're not sure to get the absolute maximum. There are several valleys to travel down in the minimization, and you could travel down the wrong valley. So some Russian mathematicians made some interesting solution procedures. And this, I suppose you cannot see the numbers, but the outcome of our calculation was that, for example, Germany had to reduce by 90% from 1990 to 2010, and Bulgaria by 57%. And the Greece, I remember, was practically nothing because their emission landed where it didn't do any harm. So you have a vast range of percentage reduction from 1990 to 2010. And the politicians, the negotiators, basically just signed. They adjusted the obligation of Ukraine a little bit because it was too expensive for them. And otherwise they signed, and this is the Göteborg Protocol, and the 2010 is now passed, and it has basically been fulfilled. And if you ask me what had happened without the protocol, I would have said a lot would have been fulfilled anyway because of the change of technology and so on, and the fall of the communist regimes, which had very old-fashioned technology. But I think also this contributed to the reduction of the problem, and now it is not a problem anymore because everything is forgotten, and the forest in the Erzgebirge is healthy again, and everything is fine, and it's time past. So that's it, I guess. But the convention is still keeping an eye on this, and it was interesting because I had to work with forest scientists and aquatic scientists and all sorts of scientists, so I know some soil chemistry, and it's very exciting to go across the scientific fields. I think that's very, very interesting. So now I think I was headhunted to the Norwegian Met Service to do this modeling, but gradually then I got other jobs in the Met Service, and suddenly I became director there in 2000, and as Alain says, I think I'm the longest serving Met Service director in Europe for the time being. So, and then we had the problem that our ministry wanted us to generate some more revenue. And there was a report saying that we should sell our data, and we took higher prices than the Swedes. We were always like to beat the Swedes also with higher prices, we thought. We didn't sell much. So, and then we lowered the prices by 50%, and I thought it would be a long line outside the institute that wanted to buy our fantastic temperatures and so on. but there wasn't. And the sales went a little up, but the revenue went down because the increase in sales amount didn't compensate for the reduced price. So after a while we gave up and we made the data free, and we wondered what had happened and why. So this is now a modern weather forecast generated from one of our excellent models that Met Services run everywhere in Norway. However, Met Services in general, or very often, are not allowed to publish this, at least not for free, because this is supposed to be done by the private sector. That's at least some ideological thinking by quite a few of the governments around Europe now. So a weather forecast is a common good, which means that if you have a weather forecast for Sofia, for example, then all the population in Sofia can use it without the quality being reduced for that particular forecast. If I had a glass of beer here and I drank half of it and I asked Harry if he would have some beer, he would probably say no, because this shows that the glass of beer is not a common good in economic theory. It can only be used by one person without the quality being reduced. But obviously, I was asking him to use a product of reduced quality. So, if you commercialize, let's see now, if you commercialize a common good and sell it, then you need to prevent those that are not paying from getting it. Otherwise, you can't sell it. So you need to protect it. But the investments are the same. The users will be much fewer. So some examples here. A weather forecast is produced by a very expensive infrastructure. This is, thank you WMO for providing this figure, used by many. This infrastructure is financed by taxpayers in the whole world. It's public money that measures temperatures, buys supercomputers or pays for them, etc., etc. It's all tax. We all pay tax. And all taxpayers of all countries, in a way, unite to provide this. There's a small addition to that comes from commercial activity in these institutes, but the overwhelmingly large part is from taxpayers' money. And then you have the fact that Met Services are required to generate more revenue by their ministries because of the financial crisis. And in a tough economic situation, when the director of the Met Service has to think from one year to the next, there's no incentive for that director to make the data free. It will only create trouble for him in the short term. In the long term, it would make his institute very much more used by his population, but he can't think long term when the short term is the problem. And politics and ideology can also underpin a restrictive data policy. We try to help Bangladesh, and now we understand that Bangladesh doesn't want India to have much of its observations or forecasts, so it's very difficult to get it out to the Bangladeshian population without getting it to the Indian one. So it's such problems everywhere. So it's nobody fights for the end user, the normal citizen. All think about their institutions and what is best for their institution. Nobody fights for the normal person in the population. Here is just as an example, policies, prices for one single synop. Okay, if you are not another Met Institute, but you are somebody who wants to use the synop for something, you have to buy it if it is not essential data. And in very many countries in Europe, most observations are additional, not essential in the Resolution 40 meaning of the word. So this is the price you have to pay. And it's very variable, and if you are a service provider, you have to pay much more than if you are an end user. End users, they don't buy this at all, because if you are a normal person in a family, you don't use your family budget to buy temperatures, or it's meaningless. But for service providers, it's relevant, of course. We need a private sector. We need a private sector to give specialized forecasts to everybody that needs specialized forecasts, and where you can establish a normal customer-provider relationships. The customer says, I need this, and this is not good enough, and so on, and the provider has to find a way to earn more money to make the customer more satisfied. This doesn't work between the general public and an institute. This mechanism is not existing, and if a man in the street complains, nobody listens to him anyway. But would you start a private meteorological firm if you had to pay, if you needed all European synops and you start with the Danish ones, and you had to pay 54,668 euros for all Danish synops in 1 year? This just prevents people from setting up new private meteorological firms. The large ones can handle this. They can afford to pay for it. But if you want to start a new firm, you can't. So this protects the existing system. And you might say it's a sly agreement, a silent agreement between the private sector and the institute, so that at least they have a stable equilibrium. I had to say something controversial here. So, this I already said. Only those who pay. If you commercialize a meteogram like this, only those who pay will get it. Those who don't pay will get wishy-washy text forecasts. In Norway, shifting breeze, doesn't say much. And they don't get the quality of the new numerical models. And this will give a large economic loss to society, because many decisions will be taken on data that are not the best possible data. So basically decisions taken on a not very well informed basis. But that scientific loss is not in the budgets at the institutes or the budgets of the state or government, so you don't see it. Okay, so now in Norway, Sweden and Finland and Iceland, we give out this type of information for free. It's directed at the end user. The end user needs this. The service providers, the commercial meteorological firms, they can produce this, but they can make it more sophisticated towards their business partner. But what happens if we do this? Well, at our website, yr.no, we have now 9 million unique users per week. But this is nothing compared to the downloads, and we also make meteograms from the ECMWF fields, so we transform the fields into one and one meteogram, 10-day meteogram for a specific geographic location, and we have 9 million locations in the world, and you can download it for free, but only one by one, so it's directed towards the end user. So the private sector still buys the geographical meteorological fields from ECMWF because they can't base themselves on this. So in a way, I can say that the private sector buys fields from ECMWF, transforms them into meteograms, and the ECMWF does not want money for this. So in a way, they are saying that based on this, after this transformation, they have no intellectual property rights anymore to the end product. So we do this for ECMWF meteograms, and I will now show you for which geographical points people download ECMWF calculations. And here you see it. And we have for this, this is not 30 million, that's the present number is 100 million downloads per day. Sorry for this slightly outdated figure. Last summer it was 100 million downloads per day. If you look at South Africa, for example, a lot of South African farmers get the ECMWF forecasts in this way. The National Met Service of South Africa runs the very nice and very good unified model from the UK Met Service. But they sell the data, and they sell it at a rather high price, so the farmers can't afford to buy it. So this is the case. This is the effect of the total meteorological system. There is an undersupply of modern accurate forecasts to the end user. That's what's happening now. And this I can't do much about other than do this. And I'm not breaking any rules in doing this. That's my, at least that's my legal analysis and my chief legal officer's legal analysis. So this is all I want to say. There's something not functioning well in the Met Service system of the world. WMO is not very interested in this. I have noticed they don't want to burn their fingers. It's a sensitive area. We need the private sector to do business with other private firms. We need the National Met Service to provide modern, and we need ECMWF to provide modern forecasts to the end users that need this in their daily life. Thank you for your attention.
Okay, you willing to take questions?
If there are any.
Okay. Okay, thank you, Anton, for this very interesting presentation. I just asked him, he's quite happy to take questions. Yeah, there's one at the back. Do we have a microphone that can... Oh. There's a microphone on the floor, yeah.
There are a lot of companies that combine their web services with commercial, so can you comment on that?
To combine commercial services with a weather service? Yeah, firstly, if you give a weather forecast together with advertisements, it diverts your attention. National weather services are still government institutions. They should give official government information on the weather, and this should not be blurred by advertisements. This is one thing. Another thing is that I'm not a great fan of commercial activity by governmental institutes because the two cultures are so different. I had a commercial director, and I had to throw him out of the top management of the institute because sitting there he got information that the other commercial actors didn't get. And we had a chairman of the board who was very puristic in his approach. So I threw him out. And I didn't tell him much. And he said to me, Anton, you're a bad boss. And I said, yes, that's right. So he took his 7 best persons with him and went to Storm Geo, the largest commercial actor in Norway, and I congratulated him on the move. So we still have some commercial, let's say, about 8% of the budget is from purely commercial activities. With that, I mean in direct competition with the private sector, not just that we get money for it, but that we actually compete, subject to competition laws. That's difficult for us, but it gives us some understanding of what the customers want, and they are sometimes advanced, and we learn something from it. So I would have wished that the National Met Services would not have done commercial activities at all. But I'm afraid this would make many of them go too much to sleep, and that is my problem. Because the pressure from the general public is not high enough. But now that we give out these metograms, we get a lot of complaints from everybody, and this is, of course, much better than it was.
Okay, Rick? Yes. I'll give you this here.
So I'm Rick Anthus from the United States. I'm interested in what is the Oslo Declaration, and how does it differ or similar to WMO 40, and what is the status of both?
The status of Resolution 40 is, of course, very high. It's approved by the 12th Meteorological Congress. The Oslo Declaration was something I think it was Germany that really wanted this meeting. And because many Met Service directors, in Europe, they are really for free data, but they are unable to provide it because of their ministries, and they wanted the meeting to try and improve that situation. That was the agenda of many of them. But some don't want free data, and this Oslo Declaration shows exactly how far we can go in that direction. I don't remember the text. Perhaps Alain has it in his head. But it's going slowly it's going very slowly in the free data direction. The Commission in Brussels wants free data, clearly in Copernicus and so on, but the National Met Services and the National Finance Ministries, in many cases, they don't want it. I think Resolution 40 is really a disaster for meteorology as it is being practiced now. I think Poland has 20 free synops and hundreds of expensive ones. And since you are from the United States, I could say that the National Weather Service is not allowed to produce meteograms because that goes too far into what the private sector should do in the States. And nobody highlights this, not even the National Weather Service.
Yeah, Anton, I would like to follow up on your last point. Where do you see the border between raw data supply and services supply? Paying for data is one thing which can prohibit new companies being created, but on the other hand, if you already have 100 million downloads for a finished service, I think that would also prevent business to grow.
I'm not sure it prevents much business at all, because it's only end users that download it, and it's designed in that way. So that's my understanding of it. So I think nobody fights for the general public. I think the general public should get free modern weather forecasts, just as the text forecasts were modern in 1945. Why should the new developments be be withheld to the general public and be commercialized. The general public is paying tax. It's entitled to get progress, and they need it. They plan now on hourly basis. They understand the uncertainty of the forecast, and they use it for what they're worth. So this is what I think. Not sure I understand the question entirely, but never mind. So, how can I?
Any other question?
Yeah. Thank you, Anton. I would like to ask what is your opinion about the balance of operational work and scientific work or research in med service?
Interesting question. In our institute in Norway, we have a research department of about 80, mostly very, very good scientists and forecasters. And after 4 years, the forecasters don't remember how it was to be a scientist, and the scientists are deeply into the models. So we have if you draw a competence profile, it has a double maximum with nothing in between. And if you are a customer, you get either the scientific opinion or the forecaster opinion, and they are partly nearly enemies. One of them likes it when the other has problems, you see. So that confuses the customer, and it's not very good for the institute, and I'm trying to do something now with this to force them to work together and quarrel together in a new department where scientists and forecasters and information technology experts and communication experts are going to work together on specific projects on loan from their mother departments, and then when the job is done after a year and a half, going back. And I don't know how this will succeed. Probably it might not succeed, but we must try, because these cultures are too different, and competence profiles are too different, and it's not good for the institute.
Okay. I see no further question. Just to comment, when I left ECMWF in 2008, there were discussions about data policy, and still the case. Hasn't really changed.
ECMWF is just where it was on that, and I think the world's best forecasts are, in a way, efficiently deprived from the use by farmers and other normal persons around the world, and I think it's a tragedy. Without the large observation system, satellites, weather radars, traditional observations, radio soundings, ECMWF would not be able to provide these excellent forecasts, and the basis is all paid by the taxpayers. I think this is there's something wrong with the system. Thank you very much.
Okay. Thank you, Anton. Thank you. Okay, I think that takes us to the end of this ceremony session. Congratulations all round to all the recipients of the awards. Once again, well done. And I think it's coffee time now. Thank you all for coming.